My name is Elise, and I will be reviewing this problem on thermodynamics, finding if a reaction is spontaneous using delta G, delta H, and delta S. So this problem is 18.6 in the extra problem set, and it reads, given the following reaction, calculate delta H, delta S, and delta G, and determine whether it is spontaneous at all temperatures, non-spontaneous in the forward direction at any temperatures, or spontaneous only at low temperatures or only at high temperatures. And the reaction is nitrogen gas plus fluorine gas forms nitrogen fluorine gas. So the first thing we want to think about is what we're finding. So we're trying to find those delta H, delta S, and delta G values for the reaction using H, S, and G for each of those elements or molecules. And then we're going to use those, and based on what those values are, we're going to try and find all of those different things it's asking about when the reaction will be spontaneous. So the first step we want to do is make sure we just balance this equation. So we can see that we have one nitrogen on the right and 2 on the left, which means that that nitrogen fluorine needs a 3, and then that gives us 6 fluorines, so we need a 3 in the fluorine gas. So that's what it looks like balanced. And then the next thing we're going to do is just what I like to do is write out all the values from the tables in the back of the textbook. So those are these as follows. So for H, we have it in kilojoules per mole, for G in kilojoules per mole, and for S in joules per mole Kelvin. And so when we have them all right here, I think it makes it a lot easier to do the math. And the math we're doing is pretty simple. It's just the like very basic delta whatever is the products minus the reactants. And then of course we want to make sure that we are including the mole values in that. So for example, multiplying H of say NF3 by 2. So the first thing that we're going to do is delta H. So I have it all written out ahead of time, but basically you see we have 2 moles because the product NF3, there are 2 moles of it. So 2 moles times negative 132.1 kilojoules per mole, which is that NF3 H value, and then minus the reactants, which is 1 mole times 0 kilojoules per mole and 3 moles times 0 kilojoules per mole. And that just all adds up to negative 264.2 kilojoules per mole. And then we're going to do pretty much the same process, but with the G values for free energy. So we have the same 2 moles, 1 mole, 3 moles for the 2 moles of product, and then the 1 and 3 moles of the reactants with the G values. So 2 moles of negative 90.6 kilojoule per mole minus, and then the reactant 0 kilojoules per mole times 1 mole plus 3 moles times 0 kilojoules per mole, which adds up to negative 181.2 kilojoules per mole. And then for that final value, S, again, the same process, you're going to plug it in. So it's those 2 moles of NF3 times the value of 260.8. And then minus the reactants, which is 1 mole times 191.6 joules per mole Kelvin, plus 3 moles of fluorine gas times 202.79 joules per mole Kelvin, which adds up to negative 278.4 joules per mole Kelvin. And we want to make sure we have the right number of significant figures there. Since it's an addition subtraction reaction, we just want to go to the 10th place since that is our fewest number of decimal points that we have in the reaction. So the next thing we're going to do is we just want to make sure that we understand what these values mean. So we're going to be thinking about this with the reaction for delta G. So the first thing I just thought about was like delta G, the free energy, is negative at standard conditions, which means that at standard conditions, it will be spontaneous, but we don't know what it would be for those different temperatures. So we're going to go ahead and look at this equation. So Gibbs free energy equals the change in H minus T times delta S. So this is sort of how it is in the packet. You might remember a pretty simple way to do it. I'm not going to plug in any values. I'm just going to think about the signs. So we have a negative delta H and a negative delta S. And so if you just kind of do a little algebra, very little algebra, you can see that we have a negative number plus the temperature. So if we want delta G to be a negative number, because when delta G is negative, the reaction is spontaneous, then we know that that can only happen at low temperatures. So basically where T is going to be pretty small, so that value doesn't end up being even bigger than delta H. So since delta G is less than 0 at low temperatures, the reaction is spontaneous in the forward direction at these low temperatures. So just to summarize, we went through and we found delta G, delta H, and delta S, just using those numbers we were given in the textbook and some pretty basic addition and subtraction. And then we used those, and understanding that a negative free energy means that it's spontaneous, we can sort of extrapolate what kinds of temperatures we will continue to have a spontaneous reaction at. Yay.